Okay, logarithms might sound a little bit confusing so far, but let's look at this three examples here. When we started the course way back at the beginning, if I said x equals 2 to the 5th, you'd say 2 to the 5th is 2 times 2 times 2 times 2 times 2, 5 2's, which was equal to 32. So 2 times 2 times 2 times 2 times 2, x equals 32. Okay. Now, as we moved a little further in the course, we got into exponents. X to the exponent 5 is equal to 32. So how I solved that was I said, okay, the fifth root of x to the 5th equals the fifth root of 32. You could do that, or you could say x to the 5th to the 1/5 equals 32 to the 1/5, right? And then you could multiply the exponents. Remember, I could do this on both sides. X, take the 1/5 of both sides. Multiply the exponents. 5 times 1/5 give me x to the 1. And if you take your calculator, 32 to the 1/5 is 2, right? Is 2. But what we haven't learned is what happens if x is in the exponent. And we started last week a little bit with exponential functions. So how do we solve it if x is in the exponent? And that's what we're going to look at this week. Okay? We're going to look at logarithms, and we call them logs for short, which will allow us to solve this problem here where x is in the exponent. Now we know, because the way I've set it up here, if we use a different color, I'm using the same example every time, right? 2 to the 5th, all right? I'm kind of using 2 to the 5th equals 32, but in each case, I'm just leaving a different part unsolved, and then I have to solve it. So we know that answer is going to be 5, but we have to use logarithms to figure out how to get there. So be patient with it. Keep going to the next few slides, and it'll make sense to you. And it is that LOG button on your calculator that you probably never used before. But hang in there. Keep going.